Hi Shivani, it's great to have you as an interviewer. And why don't you tell me about yourself?
Interview-Shivani.Thakkar. Currently, I'm doing Masters in Computer Science from University of Texas at Dallas, and I have completed 3 semesters. One more semester is left for my graduation, and presently I'm doing internship at a company called Battelle, which is based in Columbus, Ohio. So I joined from January 2019, and it is a co-op position, so the position will be I'll be working here until August 2019. And past summer I interned at a startup in Seattle. So both of the positions are software development intern. And yeah so
What kind of
I yeah
what kind of
so
mhm, Go
sorry.
ahead. Go ahead. Go ahead.
Yeah, so past summer, as I said, that I was working as software engineer intern. I was the part of the API team. So my internship duration was of 11 weeks, and they divided my work across weeks, like right from requirements gathering, then writing the design document, then coding a module, then testing and deployment. So I got exposure to the entire software development lifecycle, and they were following agile methodology, so I'm quite familiar with like sprint planning and sprint retrospection meetings and all. And the company was related to healthcare, so I was majorly involved in writing APIs for patient management. And and the technologies which were used were Java, Spring Boot, and concepts of REST and all. And as I say that I went through the entire development life cycle, so I have written the unit test and integration test, and I've also done the performance testing of the API which I wrote. And I got a little exposure of the containerization, not much, but they included that in my roadmap, but due to like lack of time I could not do it. But yeah, like I just know the basics of what they were using. And here also I'm in health analytics team, so I'm working on 3 projects. So all are related to healthcare, and they all of them have like different technologies. So one is having almost like two, they are using Java struts. And then one of them is using Apache Solar for indexing. And then they are using Hibernate, then Postgres as a database. And in one of the project is like a simulation of a healthcare system, so they are just coding in basic Python. But they are also writing the unit test and also like I got to know about the Mockito and Patch and all those concepts regarding testing in Python.
Got
So
it.
yeah.
That is a great experience to have. So, how would you define what's an API? If I am a 5-year-old and I don't know anything about software, how would you define what is an API and what's the need of an API?
Uh, like API is like a kind of, you can tell as a functionality, which is like a small module kind of thing. So like suppose you have like one functionality. So instead of incorporating that code everywhere, in like you expose an API. So and it's like, I mean, it there are two advantages. One is like reusability, so like we can call the same function again and again. And another thing is that if another company or like another institution wants to like use our API, so we can expose that feature to them as well. So
Got it. Got it. And you mentioned you went through unit testing as well as performance testing. What kind of frameworks you use for unit testing?
unit testing was basically like Java only, so JUnit test.
Okay.
But for performance testing, I used Ansible.
Okay, got it. All right, let's move to the coding part of the conversation, and let me share my screen.
Yeah.
Can you see it?
Yeah.
I'm giving you the remote. If you want to write on in here, then you can write as well. And I will not be disturbing you in between. Just read the question. You can move around the screen, and if you have any questions,
Mm-hmm.
then shoot them. Okay.
Okay. So I'll just read out the question. So that I can start. The question is lowest common ancestor of a binary search tree. So, given a binary search tree, find the lowest common ancestor of two given nodes in the BST. According to the definition of LCA, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants. So, we are given a binary search tree, and the function definition here, the root is given, the first node P and the second node Q is given. So my approach, as I can see that in the tree node definition, I have the value left and right. I don't have the parent pointer, but yeah, I have the P and Q. So my approach to this problem will be like, if I have a parent pointer kind of thing in this tree node structure, so I can do one thing that like I have the two nodes like P and Q, and then I can start from that. So um, I'll uh, I'll like I'll run a loop like kind of thing, like until like P dot parent becomes the like Q dot parent. So until I find a common node, I'll just traverse upwards and upward from the P and the Q. And at the point when this loop terminates, I can say that they have a common ancestor. And if I don't find any common thing, then just one second. So in this example, P is equal to 2 and Q is equal to 8. So like P's 2's parent is 6, 8's parent is 6. So that terminates at the root node. So I can say that the lowest common ancestor is 6. Then in the second example, P is equal to 2 and Q is equal to 4. So okay, so if I do 2's parent, then it will be 6, but 4's parent is 2. So basically I can have one another thing, that if I know the level at which the node is, so I can just traverse the like I can do the node is like the node parent is equal to node dot parent kind of thing, until both of that levels reach at the same level. And then I can just find the common parent. So here the parent of 4 is 2. So like they are both at the same level now. So I can say that the lowest common ancestor of 2 and 4 is 2.
All right. And how would you find the level?
Level I can find recursively. I can have the like compute the levels, like as and when I go downwards, I can compute the levels.
It's not still not clear. So you will be traversing from the root to every level, and then you will be recording the levels. So basically, you are doing a breadth first search of each P and Q first to determine the levels, and then you will be going up.
Yeah.
All right. Okay. Any other approach that you can think of?
If I have to use the root node, if I don't have the parent node, I can do one thing. I can start from the root, and I have the P and Q as well. So hmm. So I can use the property of the binary search tree. Um, if I have P and Q, I will be knowing the values of P and Q as well. So like I can compare. So the first example is like 2 and 8. So so 2 is on the left side of 6 because it's less, and 8 is on the right side. So mm,
Don't worry, we'll come back to this question.
okay, yeah, okay. Yeah, I'll just read out the question.
Sure.
Given and non-negative integers a1, a2, an, where each represents a point at coordinate I, ai, and vertical lines are drawn such that two endpoints of the line is at I, ai, and I, 0, and find two lines which together with x-axis forms a container such that the container contains the most water. You may not slant the container, and n is at least 2. Okay. Um, yeah, so the brute force approach to this problem can be here the goal is to find the maximum area enclosed by these vertical lines. As it can be visualized from the figure that the area enclosed we can run two loops for the height array, and picking each of them, and we can find the maximum area. So it will be because it will be limited by the shorter vertical line, so we can take the minimum of the two of them, and then we can multiply it with the width. So the height will be the minimum of the short, like the height 1 and height 2, and we can multiply it with the difference of like the x-axis difference of the two vertical lines. So that can be the brute force approach for this. So the time complexity will be O of n square. So we can do one more thing, that as we know that the area, maximum area enclosed is limited on the like by the shorter vertical line. So we can use a better approach of two-pointer solution. So like suppose my left pointer is at the leftmost end and the right pointer is the right end. So we can like find the maximum area, like as I just said, that by taking the minimum of the height of L and height of R and into the R minus L. Then we can do one thing, that as I say, that it's depending on the smaller one. So our goal is to get more area, as like more area as possible. So like if height of L is less than height of R, we can increment L, so that like if we find a vertical bar which is at a more height, we can do L plus plus. And if height of L is greater than height of R, that means the rth height is smaller, so we can do R minus minus. And this will just continue, and at the end of the loop we'll have the maximum area. Like at each step we can track the maximum, and like at the end we'll get the maximum.
And what will be
when L and R like, while we can have a condition like while L is less than R, so when L is equal to R, at that point will terminate and we can have the maximum.
Got it. And what will be the time complexity of this solution?
This will be O of n, because as we are just iterating for the length of the height array.
Got it. All right, let's go to this question.
Okay. Merge to sorted list. So, and return it as a new list. The new list should be made by splicing together the nodes of the first two lists. So for this approach, we can have two pointers for this two list. So suppose for the list 1 we have pointer 1 and another is pointer 2. So it will just point to the head of both of them, and then we can compare the value. Like we can have a new head kind of thing, which is the head of the answer list. So like if we compare the value of the head of the, like the value of the node of the first list and the second list, whoever is smaller, we can append that value to the new list. And then like if, like here we can see that it is 1 2 4 1 3 4. So here we can keep the condition as less than or equal to. So the list one's nodes value is 1, which is less than or equal to 1. So we'll append 1 to the new list, and then we'll just increment the pointer. So the pointer 1 will point to 2 now, and pointer 2 will be pointing at 1. So now we can compare that 2 and 1. So the 1 is smaller, so we'll append 1 to the answer list, and then pointer 2 will increment. So pointer 2 is now pointing to 3 and pointer 1 is pointing to 2, and then the same way it will go ahead, and we can store the values to the new list, and we can get the output list. And suppose if one of the list terminates, so like if one of the list is ending, so that means that the remaining elements of the second list will be the greater amongst which are left. So we can just append all of those in the output list in the same order.
Got it. All right. Can you share your screen, and you can choose any of the text editors that you prefer.
Okay. Just 1 second.
Mhm.
I think.
So if you hover on the screen, there is a green button.
Yeah. Actually, I was looking for a text. I generally use Sublime, but I don't have Sublime in my new laptop. So, just 1 second. Share. Yeah.
All right. So we have to design an LRU cache.
Okay. Okay. So, like I think the operation will be the get and put for this. So as the name suggests, it is a least recently used cache. So as every cache has a capacity, so this will also have a capacity. So we can have like should I like write the code or a pseudo code or what kind of thing?
How would you prefer to start?
I think I can start by just explaining like what each operation will be, what data structure I'll be using for that, and then I can go for writing.
Sure.
So as I said, it will have one capacity and it will have one variable called size, which can track the current size of the cache. Uh, like as the methods are get and put, so if we want the minimum time complexity for that, it can be O of 1, so we'll be requiring a data structure like hash map. So and another thing is that we want to um, like as it is a least recently used cache, so whenever we are like inserting elements into this cache, and if the capacity is reached, so we'll have to remove the least recently used one, and we'll have to push the new inserted one as the most frequent one. So we'll be needing a kind of a structure in which we'll be like adding a key or like on what I say, like an entry to the beginning, and we'll have to remove a thing from the end kind of thing. So like we'll have to insert from the beginning and remove from the end. So like hash map will be for get and put. So like to have such a thing in which we can insert from the beginning and remove from the end, we can use something called doubly linked list. Our doubly linked list will be having a previous and the next node, next pointers, and it will be having a key and a value thing. So in the hash map, we can have here I assume that our key will be an integer. So in the hash map, the key can be an integer, and the value can be the node of the doubly linked list. So so whenever like we are doing a get operation, so we can check that if that key is already there in the hash map. So if it is there, then we can take the we can get the value that which will be the node of the doubly linked list, and from that we can get the dot well property of that doubly linked list, and then we can return that thing. um, like for put method, we'll have to check.
Quick question. So once you're getting, let's say, uh, so can you give me remote?
Yes, it's just clicking that, right?
No. So if you hover down, then there is an arrowhead.
Yeah, there is a remote control. So
Yeah. If you click on that, then you have to click on my name as well.
okay, 1 second. Yes. Okay. Yeah, I think you got. Hello. 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 I'm not getting the. Hello.
Hello. There was some problem
Okay.
because yeah, that's fine. Can you do can you write a hash map or an object or a dictionary in which there is 11223333.
112233.
Yeah, and can you put that in a key value pair in an object?
Like do
Like just write a dictionary. Uh,
like hash map kind of thing. Should I, like, whatever I just mentioned, should I write in that way? So here the key will be the 1, as I said. Then the value will be the node. So I can use DLL.
mm.
And if I say that the key will be the key, then the value will be the value which is provided, that will be 1. Then it will be having a previous pointer and a next pointer. So
So what all operations happen when once we invoke the get function? Let's say
uh,
get one.
okay, so if I'm doing get 1, so first I'll just check in my hash map that if 1 is already there or not. Like I can check like one, map dot contains key 1.
Mm-hmm.
So if it is there, then I can just get the value which will not which will be nothing but this doubly linked list node.
Mm-hmm.
So then I can return the value field of this DLL.
Okay.
Yeah.
Any other thing that you have to do?
And if I'm doing any operation in a cache, so that means that that thing should move to the front of the list.
Okay.
So that says that I just accessed, or like I mean used, as the name mentioned, least recently used. So I just used this thing. So I'll just move this node to the front of the list, so I can have one method which can just like move that node to the front. So like I can have like two methods. One is the remove node and the add node. So remove node will just remove the node from its place, and add node will just add it to the front of the list.
And what happens in the put operation?
In the put operation, there are two possibilities that if I already have this key in the hash map, and if I don't have. So if I already have this key in the hash map, so then I can just override the value which is already there. So, and then I can just do this same thing. I can like put that value to the front of the list, so that because I just used I just accessed that thing. And another thing is that if I don't have that key in the hash map, then I can just um, create a node with this key value. And I can um, I can do the same thing. Then like after creating this node, I'll just put the key in the map and the value of this node, and I'll just move that node to the front of the list.
Got it.
uh, yeah. And there is one more thing, that if it reaches the capacity, so
Mhm.
if the size reaches the capacity, I can just remove the last node in the doubly linked list, so
Yeah,
that
sounds great.
yeah.
So what's your preferred language?
Java.
All right, let's write some code.
Okay.
Okay, here's a bit of twist. So rather than implementing the whole doubly linked list,
Mhm.
what we can use is we can use an alternate data structure. We might be messing up the time complexity, but so what's the time complexity of both get and put operations in the last discussion we had?
It is over fun because like
Okay.
we are using Hashma.
Okay, we can use a simpler data structure, but even if it ends up messing up our complexity in any of the operations, whether it is get or put. So, what kind of data structure that comes to your mind? It might not it so that we are not using a doubly linked list.
Okay. So not a doubly linked list. So maybe we can just use a queue.
Yeah. Okay. But what will be? But the order in the queue will be.
But then we'll be requiring something like double-ended queue, because we want to remove from the front
No,
and
no. Yeah. So what I'm saying is that we can mess up the time complexity even if we have a brute force kind of solution with where it is O of n, that is acceptable also.
okay.
All right. So so let's do it this way, that we write a queue rather than a doubly linked list. Okay.
Okay.
All right.
So for queue, but okay. Queue, then I'll have to like if I if it reaches the capacity, like I can't have this concept, so I can just add in the queue when the values comes, and when it reaches the capacity, then I'll have to remove the rest of the elements from the queue. Then uh, yeah, so just to remove the first element which was least recently used, and then push, I mean, then uh, offer everything back, and then putting the new one. I mean,
Got it. Yeah, got it. Let's do the doubly linked list only. Is there any like simpler data structure than even than queue? Uh, okay, let's do doubly linked list. Then after the interview, I'll share an approach with you. Okay.
yeah, I know one. I mean, that is better than the doubly linked list, but I mean that is a use that is a feature of Java linked hash map. So it just provides this. I mean, like that is used while implementing LRU caches. So it has one argument in the constructor, so and which does everything, and we'll just have to override one method. I think remove eldest something, so that will remove the node when it reaches the capacity. And I mean, usually the linked hash map maintains the order of insert, like order of insertion.
Hmm.
But like if we use that field in the constructor, it will just like store the elements in the order of access kind of thing.
Got it. Okay, let's write some code for this one only. Which one, whichever you prefer.
Which one? I mean, using doubly linked list.
Yeah.
So I can have like DLL. I'll make a class. I can have like integer key, integer value. Then I'll have here the previous, here the next. I can have a class LRU cache. So this capacity and having the map. So the key will be the integer, and constructor I can just pass the capacity. So I can do this capacity and initialize this map. Then like should I write the add node and remove node methods for DLL, or we can assume that it's already there?
We can assume it's already there.
Okay. So get method. So I can check that if dot contains key, DLL node is equal to map dot get get then just
All
move
right.
this.
So I think I have another interview at let's say 7:35. So I'll just save 5 minutes for the feedback and quick question. So while we are on the language, why do we use static keyword?
Static is used like generally when the entire class, I mean, static is the thing, a variable which remains accessible to all the objects of the class. So if we want to have a shared object kind of thing, shared variable kind of thing, we use static. And all objects of the class can modify that value, and like when it is accessed by the another object, it will get the modified value. I
Got it.
mean, that will be just one allocate, like one variable allocated for the entire, like all set of objects.
All set of
Otherwise,
methods.
yeah. I mean,
Okay.
like, however, like how many objects you instantiate, but then also they'll be sharing this single thing.
Got it. All right. That's it, Shivani. I would. Is it okay if I share my feedback with you?
Yeah, sure.
So we started. What I loved about the conversation was your confidence, your voice, and your communication. So you have a really good communication when you are. It's the technical communication, not the English communication I am talking about. So you are able to present your ideas in a much better way. Um, you, what I really liked is your you were prompt in addressing that time complexity as well as the edge cases. Um, one of the good strengths that came out of this conversation was that we didn't start really strong in the interview. So and I am hoping that you will be so binary tree questions are generally tricky. So but the way you came back with the subsequent questions and you killed them was really amazing to see. So that's my feedback. But I'm hoping that you will be going through all the three questions and you'll be really prepared. So you scored really well in the interview. Out of a scale of 5, you scored about 4 because you were not able to solve the first one. So we do refer students who are 3.7 and higher right now. So that's it. I'll be adding you to the recommended. Let me stop the recording right now.